So how's everyone doing today? Good? Yeah? Learning lots of stuff? That was not very enthusiastic, yes. Well, that's all going to change now, right? So, well, welcome. My name is Guy Royse. I'm a developer advocate at Redis. And here's relevant social links if you want to give me a follow. I'm also on Blue Sky as guy.dev, if a lot of people have been migrating to Blue Sky. And this is a workshop on Redis, getting started. And so first, a quick show of hands. Who here has used Redis before? Okay, excellent. Have you used it from Node or from, what tech stacks have you used it with? JavaScript? C#? You use the Stack Exchange Redis probably, right? And Java is probably Jedis, or what's the other one for Java? I'm blanking right now. I should totally know what it is off the top of my head. But so you've used Redis before. We're going to use it from Node today. However, I am going to assume that you do know modern JavaScript, and by modern I mean arrow functions, const as opposed to var. So it's really not that modern. We're not going down a TypeScript path. It's just pure JavaScript. It's just easier for a workshop. That you have a basic understanding of Express in JavaScript, in Node. That said, very basic. I've got skeleton code that you'll be working with that you can do that with, that you can use. So you mostly just have to fill in the endpoints. And that you know absolutely nothing about Redis. So I'm going to start from first principles, explain what Redis is, and then we'll have a bunch of exercises to use it, explore some of its features, and then start writing code with Node to use it, and all of that. This workshop is flexible in its length. It's got a good 8 hours worth of content in it. We have 3. But it's all in a README that you can follow along at your own pace. And so if we don't make it through all of the exercises today, you can take them with you, do them at home, instead of spend time with your family and children. But you can work on this asynchronously. That's very much by design, because the awkward thing with any workshop is I'm going to present some material, and then you're going to work through some exercises, and I'm going to present some material, and you'll work through exercises. And some people will finish early, and some people will finish late, and I'm just going to, when about half of you are done, I'm going to move to the next section. And so you can move on at your own pace. So what we're going to cover in the workshop today is installing Redis and Redis Insight. Redis, and Redis Insight is a graphical user interface, a GUI that lets you access Redis. We're going to use Redis commands directly against just raw Redis commands, so gets and sets and interact with Redis directly. We're going to use Redis from Node.js, and time permitting, we'll get into using JSON and search. So that's what we're doing. We are going to be using all this to build a Bigfoot tracking API. I have other talks where I use Bigfoot as a theme, and I joke that the reason I like Bigfoot so much is because he's my father. You can see the resemblance. But we're going to build an API that lets us do searches for Bigfoot information. And most importantly, this is a workshop, not a talk shop. So I'm not going to stand up here for 3 hours and present slides to you. I'm going to stand up here for a bit and present slides, and then you're going to work, and you're going to do things, and you're going to learn things. I'm going to tell you about it, and then you're going to read about it, and then you're going to do it. That's the idea. We'll be using Express, like I said. We're using Node, so hopefully you all know Node really well. And of course, we're using Redis. And when it comes to Redis, there's a little bit of a clarification around product versions. Our product landscape is a little confusing. And so just to clarify it, and we've had a license change recently as well, which has made it even more confusing. We are going to be using Redis Community Edition. This is the free, publicly available, source available version of Redis. It has all the data structures that you know from the previous version of open source Redis. It's great. It's a cache. It makes a great database. You can use it as a session store. And but when you're using it to do clustering and that kind of stuff, that can be a fair bit of work. For what we're doing here today, that doesn't matter. We're not going to set up a cluster or anything. We're just going to run Redis locally and run commands against it. Redis is extensible. So that core Redis code, which has the gets and the sets and the hashes and the lists and those sort of things, it's extensible, and you can add to it with plugins, with modules, new commands, and new data structures. And we at Redis have implemented a few of these and bundled them together into what we used to call Redis Stack, but now is actually just part of Redis 8. So we added one so that we can store JSON in Redis as JSON, so you can actually parse the tree and do JSON path queries against it and everything. We've added search capabilities, so you can build indices to search based on various properties in those JSON files or in hashes. We've added a time series database. We're not going to talk about time series, but it's in there. And we've added probabilistic data structures as well. So we've implemented several modules to extend Redis, and we used to bundle this together with open source Redis and call it Redis Stack, but now it's just Redis 8. Now Redis 8 isn't out yet. There is a milestone release out on Docker, which we're going to be using today. So we get to use the latest, greatest, and most up-to-date version of Redis for the workshop today. I'm not sure when Redis 8 is coming out officially, but we'll have the most recent version that we can possibly have, bleeding edge. Besides that community edition of Redis, which we're going to be using, we've got Redis Cloud and Redis Software. These used to be called Redis Cloud and Redis Enterprise. And they're pretty much the same thing. It's just one's a managed cloud service that we provide, and one is something you can install on-prem. And it includes all of the modules that are part of Redis 8, that were part of Redis Stack. And in addition to that, it takes care of all the clustering for you so that you don't have to worry about when you go to scale up. This is the grown-up version of Redis, right? We're going to use the developer community edition as a single node, no clustering, anything like that, because that's all we need to do development work. But this is, I'm a big enterprise, and I need to have all this management around Redis, and so we've got cloud offerings, and we have on-premise offerings that take care of a lot of that clustering and high availability for you. And it has an easy-to-use proxy to hide all those clustering details, so your code doesn't have to change, but makes it easier to use, makes it easier to own, but more ownable as an enterprise, so on-prem or in the cloud. This is a screenshot from Redis Insight. This is the library, the GUI we're going to use. Apologies, my microphone keeps coming off my ears. I have a fat head. So Redis Insight is a GUI. On the left here, we have some data structures. Let's see, there we go. So we've got various keys in Redis. We got a hash, some JSON. On the right, we have one of them selected. So this is a GUI. You can just look at Redis and see what's in it, click on it, edit it, modify it. It's much easier than using the command line, although sometimes the command line is more appropriate. And we're going to do a bunch of stuff with Bigfoot data. And so there's a good question of, well, where are we going to get Bigfoot data? Well, there's this website called an organization called the Bigfoot Field Researchers Organization. And the Bigfoot Field Researchers Organization was founded in 1995. They are the only scientific research organization exploring the Bigfoot Sasquatch mystery. And they have a comprehensive sightings database. Now, when they say database, what they mean is a bunch of web pages. This is not what I think of when I think of a database. I think rows and columns and things I can query and those sorts of things. Well, fortunately, the internet has everything. And there's this wonderful man by the name of Tim Renner who has screen scraped the BFRO's website and turned it into a wonderful CSV file. And that is included in the repo that we're going to be working with. He used it to do data science stuff. He wanted to find out where you could find Bigfoot. And so he plotted all the locations, the latitude and longitude of every Bigfoot sighting in North America, and then applied like a scikit-learn clustering algorithm to find out where they're clustered. And he discovered that you could find Bigfoot in the woods. So he's doing the Lord's work there. He's also got a great data set of haunted places in North America, and the UFO sightings database is delightful. He did work with that as well and discovered that, for example, most UFO sightings happen within 100 kilometers of a United States Air Force base. Shocking. And the most common day of the year for a UFO sighting in North America, in the United States, is the 4th of July, Independence Day. So everyone's up there looking at fireworks. Like, is that a firework? Nah, that's a UFO. It's got to be. So that's the kind of work that Tim's doing with this data. He screen scraped it. It's for our convenience. It's great. And so this is the data that we have on Bigfoot sightings. We have, each one has a unique ID. It's just a report number. Bigfoot sighting number 8086 happened on January 15th of 1958. And then they've got a title, which is, well, the title. And they've got an observed, which is the eyewitness account. So in this case, it was a series of large human-like footprints are found on a farm near Wayne National Forest. This is actually very close to where I live. It's not me. It's probably my dad. The account here is, while doing some yard chores, we noticed a series of tracks going into the hollow on our property upon examination, and they go into the story. Bigfoot sightings have classifications. You may have heard of UFO sightings. You have like close encounters of the first, second, and third kind. Well, Bigfoot sightings have classifications of Class A, I saw Bigfoot. Class B, I have evidence of Bigfoot, like I heard a noise or I found a footprint. And Class C, which is someone told me they saw Bigfoot. The most reliable of them all. I suppose technically they're all Class C, aren't they, at this point, because I'm getting it secondhand. It's got the county and state within the United States that it happened in. This one happened in Noble County, Ohio. Got your latitude and longitude. And then location details is just text about how to find the location. Like, you know, it's down on the road, turn left at the stop sign, that sort of thing. And so this is the data that Tim screen scraped from the BFRO's website, but then he augmented it with weather data from Dark Sky, back when Dark Sky was still a thing and hadn't been bought by Apple, to include the temperature in Fahrenheit, of course, because, well, freedom. The humidity and the dew point, cloud cover, all the basic weather data that you would expect to have. And he was hoping to like maybe correlate maybe people that saw Bigfoot, it was a foggy day and it was really just a grizzly bear up on its hind legs and stuff like that. And I don't know that he ever came to any great conclusions, but the data is delightful. Some of the stories are wonderful. There are 4,586 entries in the data set. And yeah, this is what we're going to be playing with today. So hopefully you're all excited. So this is the obligatory QR code. There is a repo that we'll be using to start this workshop. So go ahead and either take that URL or use the QR code. It is, the link is completely safe. It will never give you up, nor will it let you down. And this will take you to repo, and then we'll take a look around at what's in the repo once everyone's snagged it here. So let's take a look around. Okay. So this is the repo right here in VS Code. Is that? Should be fairly readable. So just give a quick tour of what's in the repo. So we have here a binary demo. This is just a little demo for something I'm going to do later during the talk, showing you how you can store binary data in strings in Redis. The converter was just a bit of code I wrote to generate the data usefully. The important things here is there is a source folder. This source folder has a skeleton project that you'll be able to work with. And so it's just got fairly empty, not implemented things all through it. And so this will be the place where you'll be doing all the exercises. There's a solution folder which has the final version of this when we get to the end of the workshop. If you want to look ahead, if you get stuck, you can go and look and see how things are done in there. This is for where if you want to cheat. The slides for the talk are out there as well as a PDF. I literally updated them yesterday, and so they're up there. Then I made a few changes this morning, so they're already out of date. And then in here, most importantly, is the docs folder. And the docs folder is the contents of this workshop. It's what you're going to work through. And so you'll start out with instructions how to install Redis, and then doing some basic operations with Redis and moving all through this. And we will probably not get through all these today, and that's perfectly fine. So that's what's in the repo that we've just cloned, or at least browsed to. Yes, sir. It is beyond the cache. And so one last slide. This is the instructions on how to install Redis Community Edition. They are also in the documentation and the repo. It's fairly straightforward. So we're going to be using Docker. So hopefully everyone has Docker. If you don't have Docker, you'll need to install it first. And so hopefully we can do that on conference Wi-Fi. But you'll do docker run -d --name Redis, and then map port 6379 to the outside world. And then we're using Redis 8.0-M02. So this is milestone release 2. So it's a production candidate. So this is what we're going to use today. Don't use this in production yet. It's a trial. It's a candidate. But that said, it's worked pretty nicely for me, and it's got all the Redis you want. And then Redis Insight is a GUI that we're going to use, and you can get that from redis.io/insight. That will ask you to enter in personal information to download it. I'm not going to tell you that you can lie on that information because you already know that. The preferred way is actually to install it from the Microsoft Store if you're a Windows user, or the App Store if you're an Apple user. And you can just download it directly from there, and you've got it installed. So that's how you're going to install these two tools. And that's what I've got so far. We're going to go into, ladies and gentlemen, start your Redis, and go ahead and hit that installation.markdown file in that docs folder. And let's get Redis installed. So that's all I got. All right, so I'm going to go ahead and plow through and assume that everyone's waiting for Docker to download images and get everything running, and do sort of a brief introduction to what Redis is and why you should care now that you hopefully have it installed. So what is Redis? Or I had one of my bosses used to like to say, a boss that I previously had, I don't have 5 bosses, a boss that I previously had said, what's a Redis? And when you ask people what Redis is, you get a lot of different answers. The most common answer that you get is, it's a cache. This is true. It's actually false, but it's really good for a cache, but it's not what Redis is. It's a key value store. This is also true. This is closer to what Redis is. It's a giant table full of keys, and there's various values that you can store in them and retrieve for them and manipulate in them. I like to say it's a memory-first NoSQL database. That's a nice, smart-sounding, elevator pitchy way of describing what Redis is. It's memory-first in that everything in Redis is stored in memory. However, it can be persisted to disk as well if you configure Redis correctly. It's NoSQL because it's a key value store. You don't do select star from Redis where keys equal blah blah blah. The syntax is different. And it's a database because it does database things. You can store stuff in there permanently, it's replicatable, it's clusterable, it's scalable. And so I like this definition in particular. However, another one that I kind of like is saying that it's networked memory. Because what Redis ultimately is it's a giant hash table. And that giant hash table has keys, and it has values that are in those keys. And those values are all of those data structures you learned about in computer science class that you've never had to write ever since. Hash tables, linked lists, sets, these sorts of things. These are all in Redis as in-memory values that you can manipulate over a wire protocol. So Redis is that memory, those data structures stored in memory over the network. So it's networked memory. These keys can contain lots and lots and lots of data types. The most common one is a string. I find that most people, when I ask them if they use Redis and what they use it for, they say, yes, Redis is a cache, and I store strings in it. This is the example of, I'm caching an API call. And so when I hit that API the first time, I get a JSON string back, and then I shove it in Redis. And then the next time someone calls it, I pull it out of Redis instead. Strings are actually misnamed, because strings can contain text. They can also contain binary data, because it's actually not a string, it's a blob. And so if I shove a ASCII string in there, an ASCII string is effectively a binary object. But if I shove a UTF-8 string in there, then it's got encoding. If I shove an image in there, those bytes can be stored in there. So you can really store anything in a string. This is the most basic data structure in Redis. It's just a block of memory that you put stuff in. That's all it is. Since these strings are binary data, since they're binary in nature, there are a whole series of bitmap functions that you can do against these. These allow you to do things like take the bytes that are in this key and take the bytes that are in this other key and AND them together for me. So you can do things like bit masking and those sorts of things. So you can deal with it as if it's binary data. Tell me, is bit 17 set to high or low? You can do those sorts of operations against strings. You can also treat them as bit fields. And I think bit fields is the most underutilized and interesting feature in Redis. Bit fields let you extract arbitrary numbers, arbitrary integers out of the binary data in a string. And so I can say, go to position 5,913 in this string, bit 5,913, extract the 13-bit signed integer from there and give it to me, and it'll do it. And so you can go in and pull out arbitrary sections at a bit level as opposed to at a byte level. I think this is kind of neat. I think the reason it's underutilized is because it doesn't have a ton of applications. But if you're doing low-level protocol manipulation, say you've got a super low-level protocol where the first 3 bits mean it's this record type, and then the next bit is a check bit, and then you got 7 bits after that mean another thing, and you got this really compact, the stuff you do in IoT or radio and that kind of stuff. This is really powerful for those sorts of capabilities because you can just pull that number out and then just use it in a state machine, and it just works. It's brilliant. You've got hashes. Now, Redis itself is a giant hash table. And so we hash that key, and then we use it as an index for the big hash table that is Redis. But in that hash table, we can store a hash table. Yo, dog, I heard you like hash tables. And this is exactly what you think it is. It's a key, value, store. We actually call the keys in a hash table in Redis a field to disambiguate it from the keys that we have in Redis itself. So hashes have fields and values. And you've got all these methods to manipulate them in all the ways you would think. Give me all the keys and values, give me the value at this particular field, those sorts of things. You might be wondering if I can put a hash table in my hash table in my hash table. The answer is no, because the field names and the values in there, they're strings. And so just like a string, they can be binary, but they can't be another data structure. They're the same sorts of blobs. It's worth noting also that strings, I missed this at the beginning, but strings can also be integers. Internally, they can store them as numbers as well. So if you use it as a counter, there are commands that allow you to manipulate strings as numbers, and Redis will store them internally as numbers. And you can do the same thing with hashes. You've got lists. These are straight up doubly linked lists of strings. There's not really much more to say about it than that. You can push and pop to them. You can go from the left and right. There are commands to move values from one list to another. One of my favorite tricks is that you can move something from the front of the list to the end of another list, but that other list could be yourself. And so you can actually just cycle things through a linked list. So if you have a queue of things you needed to process periodically, you could just loop through it and say every 5 minutes, pull the last thing off and then push it back to the front. Pull the last thing off, push it back to the front. So you get sort of like a processing queue. You've got sets. These are the Venn diagram-y set theory things where it's a set full of strings, and you can add things to the set. You can ask the set for its cardinality. You can ask if something is a member of the set. And you can do unions and intersections with sets themselves as well. So you can take set A and set B and get the intersection of them or the union of them. Similar to sets are sorted sets. A sorted set is, well, it has all the things that a regular set does, but each value in a sorted set also, each member of a sorted set has an associated numeric value with it. It's a floating point number. And this gives it a natural sorting order that you can take advantage of. And so you can use this, for example, you can do things like, give me all of the members that have a value between X and Y. Or give me, here's a member, show me the people that are above them and below them. So you can get like a leaderboard sort of application out of it. So these are very powerful as well. There's a variety of a sorted set that's a geo set, and that numeric value that's in a sorted set becomes a geocode or a geohash of the latitude and longitude. And so I can take a bunch of locations and shove them into a geo set and do things like, here's a point on the globe, give me everything that's within a 100-kilometer radius of that point. Or give me all the things that are in a particular rectangle. There's HyperLogLog. Anyone heard of a HyperLogLog before? It's like, it sounds made up, doesn't it? It sounds like you stuttered when you say it. A friend of mine is a developer advocate at Progress Software, and his wife likes to joke about this one because she thinks it doesn't sound like it's real. A HyperLogLog is kind of like a set, but it's a probabilistic data structure, and so it's super compact and super fast and gives you inaccurate answers. You're like, why would I want something that lies to me? Well, because it's small and it's fast. And so a HyperLogLog is 12 kilobytes. You can add things to it, strings, and then you can say, how many strings have you seen? That are unique strings have you seen? And it will tell you at like a 97% accuracy. But you can't get the strings that you put into it back out because they're gone. They've been hashed away. And this is good for scale. If you're YouTube, for example, and you want to get unique viewers on a video, you really can't just add all the unique views to a set and get the cardinality of that set, because that's going to have potentially millions of entries in it, and counting them is going to be expensive. But if you use a HyperLogLog, counting them is cheap. It's an O of 1 operation. And so this gives you great performance and scalability. Probabilistic data structures are really, really neat. There's a whole host of them in Redis that are worth checking out. I have another talk on that, actually. If anyone was here last year, I did it here last year, so the video should be out there. But this is one that ships with Redis out of the box. And then last but not least, there's our event streams in Redis. These are the Kafka type things that we know and love. The experience of a stream in Redis is a little more of a white boxed experience as opposed to a black boxed experience. So you have a little more control and say, and one key contains an entire event stream. If I was building like a huge production pipeline, honestly, I hope I don't get in trouble for saying this, I wouldn't recommend using Redis streams. They don't scale in the same way that like Kafka can. But if you need a log of events that you want to process later, Redis is a good choice if you have it in production already. Right? Hey, I've got this here. I don't need to process billions of entries, every 5 minutes or anything like that. Although Redis can handle a lot of entries, but because it's a key, it's always only going to ever be on one machine. And so there's some scalability from that aspect. It scales differently. So that's sort of a quick introduction to the things that are in Redis that you can store. There are others. We've got JSON documents, you've got time series, you've got other probabilistic data structures that come from the various modules that can extend Redis they're all part of Redis 8. So, how do we interact with Redis? It stores these things. How do we talk to Redis? Well, we issue it commands. This is a lot like in a relational database, we'd send a select statement to query something, or an insert statement. There's a whole host of commands that do all sorts of things against Redis. So we ping and set a key to a value and get that key, and add things to a set, delete things, leave Redis, that sort of thing. So you issue these commands into Redis, and it gives you responses back. And it's text coming back to you. So you interact with Redis using this protocol of commands. And perhaps the most useful link that I'm going to give you today is right here. Redis.io/commands is the reference documentation for all of these commands that Redis has. And I work for Redis. I've worked for Redis for 5 years, and I still use this every single day. Because there's a lot of commands, there's a lot of things you can do. And so it's a great reference. It's actually really cool. What I think is particularly cool about this is that every command in Redis has big O notation for its performance. So when you go to use something, you know how it's going to scale. So let's go ahead and try a few commands here. I'm going to use Redis Insight, I'm going to use the CLI. I think I'm feeling like I want to use the CLI. So, is that? That looks like it's probably big enough. Can the people in the back read that? Excellent. So I'm going to do Redis-CLI. So I just ran keys star, never do this. So I wanted to make sure my database was empty. So keys star will go through and take every key in that hash table and basically give you a list of all the keys. Now that sounds fine. I just want to see a list of keys. And if you have 20 keys, it's not a big deal, or 100, or even 1,000. But if you have 1 million or 100 million, Redis has to go through every single entry in its giant hash table and then spit it out for you. And so it's got to hit that hash table 100 million times or 10 million times or whatever. And Redis, at its core, is single-threaded. And so while this keys command is running, nothing else can happen. So if you do this on a production server, you're going to get fired. Also, I have a bad habit of doing this, so please never let me touch your production servers. No. But so I entered the keys command, give it star for match all keys, and it says empty array because I have an empty database. You can do like ping, response with pong. I can say set foo equal to bar. And then if I get foo, there it is. Now if I do keys, you can see that foo is one of the keys. So this is a very easy way to interact with Redis. My favorite command of all is flush all. Commands are case insensitive. By convention, they're uppercase, but they're case insensitive. Any idea what flush all will do? Yeah, you want to know what happens when I hit enter? It does not ask, it just does it now. So it deletes all your data, flushes everything in memory, and it doesn't even ask you if you're sure. So be careful with it. This is how you interact with Redis. It's fairly straightforward, actually. And if you're using Redis Insight, let me launch Redis Insight here. Should have had it launched beforehand, but it's amateur hour for me today, so sorry. And I go here. You can see that this is Redis Insight. I don't have any keys, but I can go down here to the bottom left. There's a little CLI. And this works just like the thing that I did from the command line. So I can say set foo to bar, and we can do h set bar alpha 1. There we go. And if I go up here and refresh my list of keys, now I've got a little interactive GUI that I can see my keys with instead. If I click on the hash, it shows me the values. There we go. That looks better. I can see it's got alpha 1, and I can actually even go in and edit it and set it to like 5. And so this is another way to interact with Redis. It'll probably be the main way you interact with Redis today. So those commands, the Redis CLI and Redis Insight, what they're doing behind the scenes is they are talking over a wire protocol. This wire protocol is called RESP. I always blank on what it stands for, but you can Google it. It's like the Redis state protocol or representation. I can't remember. It's RESP. It's the wire protocol that you use to talk to Redis. You'd think after 5 years I'd have this down, wouldn't you? And so if I do like this command here, so I type in set message of the day and then greetings. So I'm setting a string to a value. What it sends behind the scenes is this. It sends *3 character turn line feed. That says, I'm going to send you 3 arguments. And then Redis just waits for the 3 arguments. And then $3 says, the first one is a string. $ means string. And 3 means that it is 3 bytes long. Okay, and then you send set, and those are the 3 bytes. Then $4 says, and the next one's a string too. And it's 4 bytes long, and then I send the key name. And then the value is another string, and it's 10 bytes long, and it's greetings. And Redis receives that, over the wire, and then it responds with plus OK. Now, there's two ways to represent strings in Redis. There are embedded strings and there are raw strings. Embedded strings, you have a pointer to, and the raw strings have a pointer to a pointer for memory management. So the embedded strings are faster, but they're only good for short values, whereas the raw strings can handle up to 512 megabytes. And so this is an embedded string because OK is in there all the time. You can think of it conceptually like the difference between being on the stack and the heap, whereas embedded strings are on the stack and raw strings are on the heap. This is just a thing Redis does internally for optimization. You don't really have any control over it. It's just a thing that happens. And so that gets turned into OK. And if we say get message of the day here, again, it's the same pattern. I have two arguments, *2. First one's 3 characters, the next one's 4 characters, and here they are. So this is the low-level protocol. You'll never need to know this. It's just interesting. And if you know Redis already, then this is a detail that you probably haven't dived into. But it is interesting that this is the protocol, and it's not that complicated. Like I could probably write some code to implement this protocol for basic things in an hour, maybe. I had a coworker that used to code a live Python Redis client as a meetup talk in an hour using this protocol. And so there's a response coming back. Greetings is longer, so it's a raw string, not an embedded string, and it comes back. So, and so it's easy to write code to use this protocol. You don't need to. There are libraries that do it for you, but you can if you want. But you can actually even just do it from the command line. So if I echo -e with all that and pipe it into netcat, it will send all of that to Redis, and then it will respond back with an appropriate result. And you can even just do it by hand. And so we're going to, because it's kind of fun. So let's try it by hand really quick. See if I can do this parlor trick. Okay. So I'm going to say, I need to look at my cheat sheet here. I can't. Can I just do that? There we go. -c-v. That's right. I couldn't remember the argument, the flags that I use. A netcat -cv. So the -c means put the character turn line feed at the end of it whenever I hit enter. V is just for verbose. And localhost 6379. I am now connected to Redis. So if I say *1, enter, $4, enter, ping, responds with Pong. If I say *2, $3, get, $3, foo, returns the bar, what I sent. So you can interact with this at a very low level. And let's go ahead and $1, whoops. Oh, I did type *1, I said $1. $4, quit. That tells Redis to close the connection. So you can actually do this, very easy to do actually. So worth noting is removing keys from Redis. So we've set a few keys, we've manipulated it, but keys get removed from Redis in a couple different ways. And some of this is why Redis makes such a great cache. You can call delete. There's a command named delete. You give it the key name, and it will free the memory, delete the key, and return. And this is the most aggressive way to remove a key in Redis, because it frees the memory and then returns the result. A more popular, or a more performant option would be to use unlink. Unlink removes the key from the hash table and returns, and then later on frees the memory. And so that memory can then be deleted by Redis asynchronously. And that keeps it from blocking the main thread that is Redis just a little bit less. It blocks it just a little bit, the amount of time it blocks it is shorter. You can also just set keys to expire. So there's an expire command. You give it a key name and a time to live in seconds. And then when those seconds expire, then it goes away. Now, it doesn't always go away immediately. Sometimes it'll stick around, but as soon as you try and get it, if it is expired, it will remove it and then return to you that it's been removed. But the most interesting way, I think, of removing keys from Redis is with an eviction policy. So Redis has a fixed amount of memory that you configure with it when you set it up. You say, never take more than 4 gigs of RAM, or whatever you want to set it to. And eviction is, what does Redis do when it's full? When you've filled it all the way up, you've stored all four gigs or 32 gigs or whatever you've set it to, when there's no more space left in Redis, what do? Well, it runs an eviction policy. And many of these will remove keys. One of them specifically won't. Eviction options vary quite a bit. There is several of them that you can choose. This is all set up in redis.config. You can set up the least recently used. And so only keys that are expired, volatile, least recently used, only keys that have an expiration set on them, and it was the one that has been used the least recently. So the oldest one. And we'll kick one of those out at random. There's all keys, LRU. That doesn't care whether there's an expiration or not. It will just say, find the key that no one's used the longest amount of time, get rid of it. No one cares. There's least frequently used. That actually embeds a little counter with each key to see how often it's used, how much it's been used. And if a key has not been used very much, then it's kicked out. And that can be either volatile keys, ones that are designed to be expired, or ones that are any key, all keys. There's volatile and all keys random. Just pick a key. I think all keys random is like the chaotic evil version of eviction because it's like, just get rid of a key, I don't care what it is. Yeah, we're going to lose something. There's also a volatile time to live. That's the one that's going to expire next. And then, of course, there's no eviction, which is the default setting. No eviction says, when Redis is full, don't let people add any more keys. So you've got a lot of choices here. LRU is usually what most people use, but you can tune this however you want. Redis is capable of persisting. So this slide's here mostly. This is my friend RJ, actually. He took that when he was down in West Virginia. But I have this slide because everyone thinks Redis is a cache, and it's in memory. And it is in memory. It's memory first. But it can be written to disk, and I just want to reinforce that message here. There are 2 ways that Redis can persist to disk. One is to use an RDB, which is a Redis database. This is simply a snapshot of Redis that's taken periodically. And it's just a snapshot of what's in Redis, written to disk. And then you can, when Redis starts back up, it reads that snapshot and applies it to memory. You can configure it to save on amount of time and number of keys. And so in this example here, we got save 3600, that's 3,600 seconds, so an hour. Save it every hour if at least one key has changed. If you changed one key and it's been 40 minutes and then the database and you shut Redis down, it will not be written to disk. And you'll lose it. Save it every 300 seconds if at least 100 keys have changed, and save it every 60 seconds if at least 10,000 keys have changed. And so what you can do here is you can adjust the amount of risk you're willing to take. If I want to write to disk more frequently, I can change the numbers so that I have less risk of loss of data if Redis were to crash for some reason. And so you have complete control over it. You can also force this to happen by using the bgsave command. So if you want to actually write it out regardless of whether you should or not, it'll do it. The other option is you have an append-only file. This is a log of every command that you've run that would modify Redis. So if I set something, or if I delete something, or I change a value, then we log that command in an append-only file. And then when Redis starts back up, we replay that file and reset all the values. Now, this can get long. And so you will sometimes use these in combination with an RDB. So the RDB loads and then the commands are applied to it. There's a bunch of config options here where you can say whether you want to do append only or not. You got to set it to yes. There's a file sync issue here. So you're writing to a file, but writing to that file doesn't necessarily write it to disk. Right? It's like a thumb drive. You know, you're supposed to right-click and unmount the thumb drive before you yank it out of the port, because if you don't, then maybe the flush hasn't been called behind the scenes. Well, what append fsync does is it lets you control explicitly how flush is called. So always means every single time someone sends a command, write it to disk. This is a bad option, but it's there because it slows down your performance. Every command now gets serialized with the disk. Makes Redis very slow. Makes it very reliable, but it makes it very slow. You can set it to no and just get what you get. And you can set it to every second, which is just basically, it calls flush every second is what it does. And you will periodically want to rewrite your append-only file, because lots of times you're gonna set a key, you're gonna modify it a few times, and you're gonna delete it. And there's gonna be a bunch of commands in there that are no longer relevant. So if I set a string 10 times, the 10th one is the only one that matters because the other 9 have been overwritten. The append-only rewrite options will rewrite the append-only file to make it shorter, so it spins up faster. And then you can trigger that automatically based on how much the file's grown, and there's a minimum file size option. So the rewrite percentage of 100 is when the file doubles, attempt to rewrite it. And you can force this by calling rewrite AOF, VG rewrite AOF as well. So that's my super quick introduction to Redis. Now you're going to go into the workshop portion of this, and there's Redis basics through Redis sets, where you're going to start using a lot of these data structures and commands with the installed Redis that you have, and start poking around with it. So this will take longer than installation. So and so have at it. So how's everyone progressing? Who's done? Okay, let's plow on then, shall we? So we've gone through the exercise, and now we've actually done things interacting with hashes and sets and linked lists and stuff in Redis. Let's take a look at building the Bigfoot tracker API. So this is actually the node portion of the workshop here. We're going to build this API, and we're going to build that using, I mentioned earlier, I'm going to mention again, we're going to build it using Express, which is all set up for you, ready to go in the source folder. We're using, of course, Node. This is beyond the cache with Redis and Node, so we're going to use Node. And of course, we're using Redis. And specifically within Redis, we're going to use RedisJSON so that we can store JSON documents in Redis. And we're going to use RedisSearch so that we can search those JSON documents and find ones that match what we want. And we're going to use all these tools to build a proper REST API. It's not a very complicated one. We've only got one data type here, sightings, but we're going to do it in the very strict definition of REST, where get gets a thing, gets all of the things. So if we do get on the sightings URL, that's going to return all of the Bigfoot sightings that we found. A post to that URL will add a thing to it, and if you call it multiple times, it will add it multiple times. It is not idempotent. A get with the ID will then return a sighting with a particular ID. A put with an ID will replace a particular value if it's there, or insert it if it's not, and this is idempotent because it will replace, if you call it multiple times, you're just replacing it with the same thing over and over again. And then the delete will remove the thing. So this is a very strict REST definition. So this is the API. There's going to be some other APIs in the source to just play with strings and stuff like that from Node as well. But this is the meat and potatoes of what we're going to be building. And to talk to Redis from JavaScript, obviously we need to get from Node in our code in JavaScript to Redis. And so how do we do that? How do we get those commands that we typed in, or that REST that was going in, how do we get that into Redis and back out? Well, we use a library called Node Redis. And it's the most popular one because when you type npm install Redis, it's the one you get. So it's got the obvious name. And if you want to check it out, the documentation out there is pretty decent. The code is actually fairly easy to read. I have actually helped write some of the documentation myself, so it'll have a little bit of my tone that you may have gotten from the workshop as well in it. But you can go to GitHub and take a look at the docs there if you get stuck. But it's, for the most part, all the commands that you enter that you've used when talking with Redis through the CLI, through Redis Insight, there's just functions that map one-to-one to them. It's really that simple. So, to use Node Redis, excuse me, of course, you have to import the create client function from the Redis package. And then you need to call create client and give it some configuration to tell it how to, what instance of Redis to connect to. In this instance here, I'm using a URL. There's actually a standard for this URL format for Redis connection strings. And they break apart like this. Obviously, you got the Redis : // which identifies it as a URL for Redis. You specify your username, followed by a colon and a password, if you have a username and password. If some of you may have anyone use the username and password combination on like web servers with a URL, HTTP, it's exactly the same format. So, and then you follow it by an @ sign. So if you go to like a website that lets you put the username and password on the URL, because that's secure, then it's exactly that same format. You'll be Alice at google.com or whatever. You got your host name, which is where Redis lives, and you've got a port. And so this is the structure of a Redis URL. If you do not provide a password, or if you don't have a username, which is very often the case with Redis, you just use a password, you don't use your username. You put the colon there and leave it blank and it'll work just fine. If you don't have a password, then just give it the host name and the port. And actually, if you're using the default port, you don't have to specify that. And in fact, if you are using localhost on port 6379, you don't have to specify anything. So you can just call create client. So here we're calling create client. That would create a client that talks to localhost port 6379. Here is creating client with a particular URL. And there's lots and lots of options here. You can actually get a little more granular with this. This is usually how I do it actually, is I'll call create client, give it the socket with a host and a port, and then the username and password here. That way if I got like special characters in my password and that kind of stuff, it doesn't get confused. It's just cleaner. Incidentally, under socket, you can provide a Unix socket as opposed to a host and a port, and it will actually talk to Redis over Unix sockets as opposed to TCP. So if you want to squeeze extra performance out, that's an option. And here's a whole bunch of the options. This is so you can look at later. There's just a bunch of them. But the main ones are the ones I talked about. Almost every time you use Redis, it's over TCP. So once you have a client created, it's not ready to be used yet. You need to connect to it. And probably one of the most common questions I've answered on Stack Overflow when it won't work is someone didn't put await right there. Because connecting to Redis is asynchronous, so you need to make sure you await that. The next most common one is they didn't call connect. That's the other common one. So you have to connect to the client and then await that connection. Once you have that, it is simply a matter of calling functions that map to all the various commands in Redis. So the set function on the connected Redis client is called, it maps to the set command. And here I'm setting foo, a string, the key foo to a string of bar. If I want to get it, then I can say redis.get and then pass in the key name. And these are all asynchronous. So the next section is to start building your API using this information. But I think I'm going to jump ahead and do a little more talky talk because I want to make sure that I cover all the slides. We're what, an hour and a half in, right? We've got till about 5 o'clock. I think there's one thing that this slide doesn't show, but I think it's worth noting. So you've got other commands like hget or hgetall, right? And so the function, the way these functions map is their camel case. Is it camel case start with a I can't remember. I never remember which one's camel case and which is anyhow. It starts with the lowercase letter, then, so it's lowercase h, get with a capital G, and then all with a capital A, right? Yeah. That's how all of these are named. So you got to kind of pull apart the words. Alternatively, you can actually pass in all uppercase versions of these. You can say .set and be all shouty and yelly, right? Or get, right? And those will work as well. And in some ways, when you get to these like hgetAll or br pop l push, which is a blocking read from the right side pop from a list, from the left side on the left side push to a list. So it's br pop l push. Trying to figure out what order the letters go in is complicated. And so just uppercasing it is actually easier. But I feel like uppercase letters in my JavaScript code look weird. They look like they should be constants from C. And so I almost always use the cased ones. So that's a little bit of just a note there. But they almost all map to one to one. So we are gonna start building our API in a minute, but I'm gonna go ahead and talk a little bit more about how these clients work, because Redis has this interesting idea of concept of pipelining and transactions. And I think these are worth talking about now, and then we can do some more coding. So pipelining is this idea of you basically keep shoving commands into Redis without waiting for a response. So if I was doing a bunch of commands against Redis, I would say get foo, and it returns foo. Get bar, and then it returns whatever's in bar. Get baz, get quux, etc. And so it's kind of like going through the drive-through to order, at McDonald's and saying, I'd like a large fry, a large fry. I'd like a large Diet Coke, large Diet Coke. I'd like a medium fry, a medium fry. That's not how you order when you go to the restaurant, right? You say, I want a large fry, a large Diet Coke, and a medium French fry. And then they repeat it back to you. This is what pipelining essentially is. I'm sending all of them, and then I'm just getting a response. So I say get foo, get bar, get baz, get quux, and then Redis responds with all of the things that I wanted to get back all at once. And this is it's less chatty, and so it's more performant. The latency doesn't impact you as much, because in this case, you've opened a socket, and you're just send, and then stuff comes back. This is hard to do from the command line, because command line is intrinsically I'm typing. But when I'm writing code, I want to do this. In Node Redis, to do this is actually really, really easy. That is pipelined. You notice something that I'm missing on there? Await. Yes, I'm missing the await. And if I don't put the await, it just queues up the command and queues up the command, queues up the command, and it will automatically pipeline all those commands. And you don't have to do anything. Super easy, but very powerful. If you want to wait until one of them finishes, if you await the last one, then all of those will process before that last one returns. So you can get a lot of performance gains by just awaiting the last Redis command in a series of commands, assuming you don't need the results. If you do need the results, you can wrap them in a promise.all, and then you will get back an array of all the results of those promises. So pipelining is very powerful. It's actually a really cool feature, and I just wanted to share it mostly. And it's very easy to do in Node Redis, because you just kind of, it's got a very natural, intuitive feel, because I'm just awaiting on things when I actually then want to hear. And you'll notice in some of the example code through the exercises that I talk about it in there as well. But there's lots of places where you need to do pipelining can give you a little extra performance, and we take advantage of it. So that's pipelining. The other thing worth talking about is transactions. So Redis has transactions. Anyone used them before? You have? Okay. They're not actually transactions, are they? Like when I think of transaction, I think of a relational database. And I do update this, update that, I call start transaction, I issue a bunch of commands to modify the database, and then I commit or I roll back. Right? That's what you think, that's what a transaction is, right? Not in Redis. I think they're actually slightly misnamed, but a transaction in Redis is something that has to happen on the same connection, because that's how it keeps track of the transaction. And what it does is it queues a series of commands. And so I can say, set this, set this, set this, set this, and those are all queued. And then when I call execute, it executes all those atomically. Because as I mentioned a couple times already, Redis is single-threaded. And so if I do set, other people can also be doing sets in between, and you can get timing issues. But if I queue up a bunch of commands and then execute that command, those queued commands, then they will all block Redis while they execute, and no one else can get in and do things while they're doing things. So it lets you do several things atomically. A transaction is started by using the word multi, because you're going to send it multiple commands. This puts that connection to Redis in transaction mode. And anything you type after that is a command that gets queued. Exec is what you run at the end of it. When you've queued all your commands, you run exec, and then it executes them. If you have run multi, and you have queued several commands, and then you decide in your code that actually, I don't want to do any of these, you can call discard, and it will throw all those queued commands away. And there is watch. One of the things you can do before you call multi is you can call watch on a key for that connection. And then when you call multi, and then do some things and call execute, call exec, if that key has been modified between before exec was called, then that exec will fail, and you'll have to do it again. So it's an optimistic locking. You're saying, watch this key. If it changes, don't execute my queued commands. If it doesn't change, go ahead and execute them. And occasionally you may need to unwatch something. I honestly have never used this, but it's there. If you watch something and then decide you don't want to call multi afterwards, you can unwatch it. Here's a simple example from the command line. I call multi. And then the prompt switches to TX mode there. And then I do a set add, the sad command, the loneliest of all Redis commands. I like pronouncing the Redis commands. I think it's funny. You got like set add and like the H increment by for a hash increment by is hinkerby. And you've got S set union is S union. I like to pronounce it sunyon or sun ion. So there, a lot of them are very fun and kind of pronounceable. But sad is perhaps the best one. So anyhow, so we've got a set at Bigfoot Sightings, Ohio, and we add the ID of 8086, and it queues up that command. And then we're going to increment a string for the sightings count. So we're, how many sightings do we have so far? And then we're going to set the values for that Bigfoot sighting into a hash. So we're doing three things at once. And we call execute, and then it runs all three of those commands, and we get the results of each of those commands back. So sad returned 1 because we added one thing to the set. Inkerby returned the count because we hadn't added anything else to the set yet, so it has a count of 1. And then hset, we added two fields to that hash, and so it returned a 2. So queued all the commands, executes them. Easy peasy. Discarding is pretty much the same thing. We're adding the same stuff, but instead of calling execute, we call discard, and it says, okay, it's thrown away, done. And so if you need to discard, that's how you do that. A caveat when using transactions. There are two types of errors that you can put into a transaction. There's a syntactic error, and there's a semantic error. The syntactic error means I have typed one of the commands wrong. So I call multi, I call sad, I call anchor, and I call HSTE because I typed it wrong. Redis will parse these commands as it's coming in and queue them. It can't parse that command because HSTE is not a valid command. And so it errors immediately, your transaction fails. You're done. It's a syntactic error, syntactically incorrect. Semantic errors, yeah, and you call exec that says, exec abort, transaction discarded because of previous errors. So your transaction, yeah.
If you make a
You'll have to rewrite the whole transaction. Yeah. So the question was, is if there's a mistake in here, like where that we made, do I have to start the transaction over or not? And the answer is yes. You have to start it over again. Normally, these won't happen in production, right? These will happen on your machine. I hope these don't happen in production. If they do, I'm judging you. Semantic errors, however, are syntactically correct, but they're wrong. So we call multi to start our transaction. We add 8086 to our set, and then we decide to call anchor. Instead of on the sightings count, we call it on the set. Now a set is a sorted set, or it's just a set. You can't increment the value of a set. That's for strings. And so that is semantically incorrect, but there's nothing syntactically wrong with it. Anchor is a command. It takes one value, which is the field. And when we execute it, it executes it dutifully, and the first one returns 1 because we added it to the set, and the second one returns an error because it was wrong. And so we have atomically executed an error. And so this will function, but this will go through Redis correctly and atomically return you an error message. So these ones are trickier to find, but it's worth knowing that it's there. When it's time to watch for changes, so all these have just been executing these queued commands atomically. But we want to put a lock on something, an optimistic lock. And so here we are watching the Bigfoot sightings for Ohio set. We call multi. We add to the Bigfoot sightings for Ohio, queues the command. We set the hash and everything. We call exec. Those two commands are queued. If someone had come in after our call to watch and before our call to exec, this would not return these values instead. You would get something different. And this is fundamentally a timing error, right? Changes can happen. I, as the green user, am watching for Bigfoot sightings in Ohio, and I call multi. And then someone, as the orange user, comes in and modifies the very field that I've watched. They added another value. And then I come in and execute my stuff, and now I've got an issue, right? This could lead to inconsistent results. And what happens here is, I'm going to point at the screen here. So we queue, and when we call exec, instead of getting our results back, we get nil back, or null. We get a null back. That means the transaction failed because someone modified a key we were watching. Now, this slide here is probably a little redundant with that one, but it's just more of the code. So watch, multi, sadd, hset, and call exec, you get nil back because someone has messed with that key. So I'm going to demo this, actually. So let me get to my, here we go. Yeah, we'll do it from both places here. That'll be fun. So we'll embiggen that. Clear the screen. Do it from here. There's CLI. So in here, we'll start here. I'll do watch. Let's there we go. We'll say watch the key foo, and watch is variadic. So you could give it as many keys as you want. Watch foo, bar, baz, whatever. And then let's do a multi. And we'll say set foo equal to bar. It's queued. And we'll say set baz equal to quux. And then we'll call exec. And that succeeded because nothing messed with it. If we do it again, let's do multi. And we'll set, discard, watch, foo, run multi, set foo to alpha, and then over here, I'm going to set foo to bravo, and then when I execute this transaction, it returns nil. So it's real. It works. So I'm going to talk a little bit about clustering here as well. Because when you cluster Redis, things won't work. Things like transactions won't work like you think they will. And this is because when you have multiple nodes of Redis and when you shard it out, a cluster has many nodes. So I've got maybe 4 servers or 3 servers. Each of those nodes can contain several running instances of Redis that can be either primaries or replicas, and sort of collectively they're referred to as a shard. And often they're spread across the nodes. But in a very simple architecture without any replicas, you would have a node, they'd have several instances running, each one of them would be a shard. The shards contain hash slots, many of them. And there are always 16,384, 16K, hash slots in any cluster. So it looks kind of like this. I've got nodes, I've got instances, and keep in mind that these shards here, could be pointing to, like if you had a primary and 2 replicas for each shard, or for each Redis instance, you would have probably replicas for like this node here, or this shard here, on the other 2 nodes. So my picture doesn't show that really well, but you would smear them across the network. And so each node would have multiple Redis instances running. Some of them are primaries, some of them are replicas from other nodes. We're just going to look at the primaries and call those shards. And the idea here is that these hash slots, these numbers, are assigned to one of the shards in a range. And so this is roughly evenly distributed from 0 to 16K. And the key thing here is that every key in Redis has to live on one and only one shard. And there's a hash slot that's assigned to it, which is based by calculating a CRC16 on the key name. And transactions cannot span hash slots because the transaction happens on the connection, which is to an individual instance of Redis sitting on a host and a port. And so this is relevant to transactions when you are working in a clustered environment. If I want to use a transaction to atomically modify things, I can't atomically modify it across shards because it's different servers, it's different processes. They're not talking to each other. This is a deliberate design choice on Redis. I mean, we could have made Redis so that all the nodes talk to each other and everything and they're more consistent, but we made a deliberate design choice to say, no, we want it to be sharded completely like this so that we can get scalability. So it's a trade-off. The hash slots for a key are computed by, like I said earlier, using a CRC16, give it the key name, modulus it with that 16K number, and that will give you a number from 0 to 16,383. And that will determine which hash slot it is, which will determine which shard gets it. Redis clusters will reshard sometimes and reallocate keys, and so there is some, if it gets out of balance, it'll smear them out a little bit better. And so the problem here is that if I take these 2 keys and I use Bigfoot sightings Ohio and Bigfoot sightings count in a transaction, the sightings in Ohio are on this shard, and the count is on this shard. And so I cannot do that atomically. It will straight up fail. You'll get a cross-slot error. So how can we resolve this? Well, you can force keys to be on a particular shard, or on the same shard. The particular shard is still a little bit arbitrary. So what you can do is you can take part of your key name, put it in curly braces. And the part in the curly braces is then used to determine the hash slot. And now, since they're the same, they're going to go to the same hash slot, and then they're going to be on the same shard. So if you have things that need to be updated together atomically, you need to put something in curly braces to ensure that they are on the same shard in the cluster. This applies to Lua scripting and and JavaScript functions that you might load into Redis. This applies to transactions. This applies to commands like set union and set enter, where you've got 2 keys. Those keys have to be on the same shard for that to operate, or you'll get a cross-slot exception because it can't union them together. This node here is not going to then ask another node questions, because then the cluster is busy talking to itself and then the scalability starts plateauing. And so this trick works for all of those things. You use the curly braces. Common candidates for curly braces are things like username. I've got a bunch of user data. I want to make sure that I update all the user data atomically. And so that's a good candidate. UUID is any kind of identifier of a thing that ties data together. You can put it in curly braces, and then you can use transactions safely. So I'm going to stop there. The next section is, there's add transactions and whatever the previous one was called. I think it's just building out the API, right? So go ahead and proceed through 13. And then we've got about an hour left. Say maybe 20 minutes. And then I'll talk a bunch more. How's everyone progressing? Do you need more time, or who's done? Okay. I should have progressed a long time ago. You need to tell me. Okay. Well, let's move on to the next section, which is JSON and search. So these are JSON and search are exactly what they sound like. JSON has a field key in Redis that can contain a JSON document, and search creates indices that let you issue commands to find JSON documents and hashes that match search criteria. JSON is fairly straightforward to use. You have a command called JSON.set. This is sort of a pattern with a lot of the modules that extend Redis. There's a dot, like a pre-named dot. So all the JSON commands start with JSON dot. All the search commands start with FT for full text dot, because it started out as a full text search engine and then expanded into other things. The probabilistic data structures start with Bloom dot, etc. Time series starts with TS. So here we say JSON.set. We give it a key name, foo. We give it a JSON path to be the root. In this case, we're doing the root because we're setting the document from nothing. If if the key has nothing in it, then this is perfectly valid. And then we give it the JSON document as just a string. I've used single quotes on the outside here, so they can use double quotes on the inside to make it readable. This totally works with Redis. It's fine. This is a valid way to type it. Once you've set something, you can get it. And actually, you can modify this too. So after I've done JSON.set foo $, I could say JSON.set foo $.baz, and then modify the value that's in baz. So you can get fine level modifications of it using set. But here we're just setting an initial document. To get it, you use JSON.get, and there's a couple different ways you can use get. If we just give it the key name with no path, it just returns the document. And you can see that the encoding is awful because it escapes all those quotes, which is why I typed it in with the single quotes in the first place. I normally, when I interact with JSON, I'll use the Redis CLI tool that I used earlier from the terminal. And anyone ever use JQ? It's like sed for JSON documents. Yeah, it's great. And I can take the output of I can do Redis CLI, JSON.get foo, $, blah, 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 pipe it into JQ, and it pretty prints the whole thing. So it's great. You can also give it a path. And if you give it a path, then it will return an array of the results of that path matching into the JSON document. Now in this case, I've given it the root path, and there's only one root, so there's an array with the entire JSON document in it. However, if I gave it a specific path like $.bar, like here, foo $.bar, it will get the value that's in that element. And so here we have an array with just the word bar in it. If you want to do something like $.bar, which would then say, go as deep as you can into the document and find all the fields that name bar, it would return an array of all the values in those bars. I presume that those would be beers. And so that's another way of interacting with the JSON document. It's interesting though, because depending on the number of arguments passed, you get different results back. And sometimes initially when you play with this can be a little confusing. You can also give it multiple paths and say JSON.get from this key, $.bar, $.baz, and $.quux. When you do this, it returns an object. And the keys in that object are the paths that you provided, and the values in those keys are arrays that match those. And so here we've done $.bar, baz, and quux. And so here you see the object, there's $.bar, and then an array, $.baz, and then an array, etc. So lots of ways to interact with these. I'm going to go ahead and just demo this here really quick. That's my next slide. And I'm going to do this from the command from here. So we'll go ahead and clean that up. Clear. And so I can do JSON.set foo $, and then give it a value here. Let's do foo : bar, comma. Whoops, that would have been a typo. Bar : 42 and baz : true. There we go. If you enter, that should work. It's out there. Excellent. And one thing worth noting here is that we're storing numbers and booleans and all these things. What Redis is doing is it takes this string and it parses it and it stores a tree in memory. And it's actually storing a boolean, and it's actually storing an integer, well, a number. It's just JavaScript after all. And it's storing a string, and so it's storing it as the things that they are, which is nice, because then you can retrieve them back out and get JSON that matches that. So if I do a JSON.get foo, you can see that that's hideously ugly. So let's make it pretty. So one of the things you can do with the Redis CLI, which is great for scripting, is you can just give it a command. And then it runs it. It's kind of handy. And you can pipe it into JQ, and now we get a pretty printed version of it. So that's much easier to read. If I do a foo and I get $.bar, I think this will give me an error because of the $sign. No, it doesn't. It's the star, not the dollar on the command line. So that gives me just that. And actually, you can do clever things, like if I want to get the values of all the fields in the root, oops, I need to put that in quotes, I believe. There we go. That's because of Linux, not because of Redis. That gets all the fields and spits the values out, because it's every field in the root. So that's really about all there is to interacting with JSON. There is, and if we go out here into Redis Insight, I go back here, refresh my key list. There's foo. If I click on it, I can see the JSON there, and I can actually modify it. I can go in here and make it false. And now it's false. So I can edit the individual values there. So, which is kind of handy. So you got JSON.get, JSON.set. There's actually a JSON.delete, which will remove something that's in a path. There's also a JSON.forget, which does exactly the same that JSON.del does, except it's actually exactly the same. And the reason that's in there is it's an Easter egg. At the time that RedisJSON was released, our chief revenue officer's name was Jason Forget. So he got enshrined into a Redis command. So that's JSON. JSON's pretty easy. There's a bunch of commands for manipulating it, for like appending to arrays and appending to strings. There's a whole bunch of commands at redis.io/commands. It's all the things that would let you manipulate it in the way that you would expect to be able to manipulate it. Search is a little trickier. It's a little more advanced. Search provides indexing. So I can create indices that let me search for all of the keys in Redis that contain JSON that start with a particular value, and then that key, and one of the values in that key is like the ID of a Bigfoot sighting, or give me all the Class A Bigfoot sightings or the Class B Bigfoot sightings. Give me all of the Bigfoot sightings where the temperature was above 75 degrees Fahrenheit. That'd be 20-something. Stuff like that. And so there's lots of commands that you can build indexes and find the documents that you want. Includes full text search, so you can take like that title of that Bigfoot sighting, or the observed, the eyewitness account, and it will allow you to do text search as language. And so it removes stop words and those sorts of things. Search also supports aggregation, so you can do group by sorts of queries where you can say, well, let's take the day of the, what day of the week do Bigfoot sightings occur on? And then aggregate them and give me counts. And you can find out that most Bigfoot sightings happen on Saturday. That's what I learned when I did it. I actually have this theory as to why that is that the Bigfoot sighting data skews towards more Bigfoot sightings in the summer and more Bigfoot sightings on weekends. Any guess as to why that is? Bingo. Yeah. People are going, that's when people are in the woods. And so what we've learned from our data is not that Bigfoot, like he doesn't show up in the winter. It's not because Bigfoot hibernates. It's because people are in the woods in winter. So it tells us more about ourselves than it does about Bigfoot. So the data is really fun. I've done a lot of ridiculous stuff with it over the years. So if we want to create an index that allows us to search for Bigfoot, we can use a command called ft.create, and we give it a name for our index. Now this is in Redis, but it's not a key. So when we call ft.create, it creates an index named whatever we give it. But you won't be able to get that by looking at your keys. There is a command ft_list, which will list all of the indices that you've created. So you can get them that way. But it's not a key. Although it does go away when you call flush all. You can say, I want to search on JSON or on hashes. So you can say any hash or any JSON documents. You can't do both. You have to choose. By default, it's hash. You can provide a prefix, one or more prefixes. These are the prefix for the key name that it will index that is of that type. So if you have a bunch of JSON documents that start with Bigfoot : sightings : then it will be picked up by the indexer and indexed, and search will be able to see it. So the prefix is just a reserved word. One is the number of prefixes you want to give it, and then so on. So if you put a 2 there, and then you can say Bigfoot sightings and Bigfoot and UFO sightings maybe or something. If it's not a JSON in this case, because we've specified JSON, it'll ignore it. There won't be an error or anything. If you don't specify prefix, it will do all JSON documents. If you don't specify on JSON, it will do all hashes instead. And then you provide it as schema. And this tells it what's in there. In the case of hashes, you just give it a field name and a type. In the case of JSON, you need to give it a little bit more. So we have a JSON path on the left. So go to $.observed, alias that as just observed without the $. And that is a text field, meaning it's full text search. So that will do all the stemming and all the stop words and all the features you would expect out of full text search. You can have a tag, so you got $.state as state. Tag is also a string, but it's not full text search, it's a keyword. And that can be comma delimited, or you can specify a different delimiter. Think of a tag as being like the tags you have under a blog post on someone's blog. It's a list of labels associated or tagging that particular piece of content. This works really well for identifiers. If you want to build relationships between your documents in Redis, where I've got a thing here and it ties to some other thing that has an ID, you could put IDs in a tag and then search on them and do like foreign key searches and that kind of stuff. There's no joins in Redis, but you can write code that reads a thing and then reads the other things. And you can use it. Tags are great for that. I tend to use this for unique identifiers. So the report ID for a Bigfoot sighting is a tag. The state in the United States is a tag. Things like that. You can do a number, a numeric. Numerics are numbers, and you can search on number ranges. And you can also do locations, do geo, and this is a longitude and a latitude that you can then search on and do radius searches and that sort of stuff. There's actually a fifth one that I don't have on here. It's because it's well out of scope of the workshop, but it's totally worth checking out, is you can define it as a vector. So you've probably heard all the buzz and rage about vector databases, right? That's like everyone can't stop talking about it. Vector databases are embeddings and vector search and those sorts of things. You can take use an AI model to generate an embedding of an image or text or audio or whatever, and get a vector of numbers. You just get it's just an array of numbers, and put that in Redis and say this is a vector, and then you can look for other things that are similar vectors. And this will allow you to use like an AI model of a picture of Bigfoot, and then someone uploads another picture and you're trying to find similar images. Or you've got a bunch of Bigfoot sightings with the text, and someone types in, I want Bigfoot sightings involving alcohol. And then the model knows that alcohol means whiskey and beer and wine, and it'll find things that match that semantically. So vector search is really cool, way out of scope for the talk. I do have a demo if people want to see it later. That'll run on this laptop. You can just bug me in the halls. It's totally fine. So there's actually 5 types there. And you can use these to create queries. The easiest query is right here. You call ft.search, give it the index name, and then you give it a query in quotes. There's the index name, there's the query in quotes. The quotes are optional if it's all one word, and there's no special characters. So you can actually just type star here, but you almost always need the quotes, so I included them. You can give it a limit and say, give me all the matches to this in rank order, starting from position 0, or whatever position you want to start at, and up to so many results. So this gives me the top 3. And you can specify the fields that you want to return. In this case, these are the fields that are specified in your schema. You can also just pass in JSON queries in here. So you can just do return $1 and it will query the entire JSON document. This is an example of what you can get back. There are various formats you can get this data in. So in this particular case, I've done a search for all the Bigfoot sightings. This is the top 3. So I get, the first thing is an integer, which is the number of Bigfoot sightings that found total that match the query. So we have 4,586 Bigfoot sightings, and then we only return 3. Then you got the key name, so right there. And then under the key name, we have the fields on that that match that key. So that's ID and state, because that's what I said to return, and then key name, and then key name. You can actually specify a limit of 0, 0, and you'll just get the count, which can be handy. You can specify a return of 0, and you'll just get the count and the keys. Because sometimes you don't want the document, you just want to know the keys. So there are ways to reduce the amount of data you have returning back. I've kind of talked about these already. These are the different data types: text, tag, numeric, geo. Text is full text search. Tag is strings that are not meant to be human read necessarily. Text is for humans. Numeric is numbers. Geo is a position. Doing a full text search on RedisSearch is pretty easy. Here I've created a simple schema. This is on a hash with a title and observed of text. And now that I've defined those fields, I call ft.search. I give it the index, and I can just give it a word, and it will search all of the text fields automatically for you. So this will find any Bigfoot sighting that has the word creek in it. And that's what it does. This will find any Bigfoot sighting that has the word creek or the word river. This will find any Bigfoot sighting that has the word creek and optionally has the word river, but it will score higher. This one is creek or river, but not both. This is creek or river and stream. These are familiar syntactical structures here. We've used this kind of stuff before. And this is creek or river and not stream. So lots of ways to search. And you can even specify specifically which field you care about. So at title :creek, the title needs to contain the word creek, and the observe field needs to contain the word river. So lots and lots of ways you can build these queries. For tags, if you want to search a tag, here we've created a tag index for state and classification. And then if we do a search on the index, we must reference the field name for a tag search. and then we put the value in curly braces. So in this case, this is going to look for all the Bigfoot sightings in the state of Ohio. That's the one I live in. This will do all the Bigfoot sightings in the state of Ohio or Kentucky. We use a pipe for the or. Kentucky's right next to Ohio, and they have amazing chicken. Spaces are perfectly acceptable. So if you're looking for a place, a tag that has a space, that'll work. That's West Virginia. Country road, take me home. Shenandoah Mountains, by the way, are not in West Virginia, even though they're in the song. And you can even do ands here as well. So this one says it must be a classification of Class A and a classification of Class B. You'll note there's a quote here on the left, right there, but not, and right there, but not on the ends. And so that's really just one line. It just didn't fit. So that's how you do it and, where it must be this tagged, this, and another thing. For numeric searches, we've got high and low temperatures here. Again, FT search. Again, field name with an @ colon, and instead of curly braces now, we use square brackets. And it's just a straight up range. And so this will get everything between 60 degrees Fahrenheit and 75 degrees Fahrenheit inclusive. If you don't have an upper bound, you can say positive infinity for one of these values. You can also say negative infinity. You can actually make them both infinity, which may seem silly, right? Why would I, right? But that will actually filter out things that aren't numbers. So that can be useful. And if you want to make them exclusive, you can put a parenthesis to the left of it. And this would be greater than 60 degrees and less than 75 degrees, but not equal to 60 or 75. For finding Bigfoot himself where he's at, we can do geo queries. So we define, in our field, we define a schema as geo. And there's an important thing. So when we shove a value into Redis that is a geo field, it is a string. In our JSON document, it is a string in the hash. And the string must be in a specific format for geo to treat it validly. And it's backwards from what almost everyone thinks it should be. So in my entire life, have always read it as latitude and then longitude. Is that the case here as well? Or do you say it the other way? I don't know. I'm legitimately curious. I don't know. Well, Redis expects it to be longitude and then latitude. And so if you make these backwards, you'll get latitude and longitude numbers that aren't valid, and then you'll get indexing errors. There used to be, I think this bug's been fixed, it's been a while, but I'll sometimes get people that are complaining, it's like, yeah, I've got 17 digits of precision in my latitude and longitude, and I'm getting an error from Redis. We fixed that so you don't get an error anymore. But if you've got that many digits of precision in your latitude and longitude, you're figuring out which side of the proton that the electron is at. 6 digits of precision is like this much, right? It's like 10 centimeters. It's way more than enough for probably anything you're working on. I mean, that's the kind, you start getting into numbers where it's like, well, there was continental drift, and so this location is in the same place that it used to be. So 4 digits I found is plenty accurate. That'll find a house, no problem. So, but it has to be in this format, exactly this format as a string. Once you've done that, then you can query this field using @location : and then in square brackets, the information for the longitude first, then the latitude, then a number for a radius, and then units. I picked miles first because I'm regrettably an American, and I love freedom units. And so you can do miles, you can do feet, you can do meters, and you can do kilometers. You will be pleased to know, however, internally Redis is using meters. And it just converts it to these others, which probably means that the miles and feet are inaccurate. But yeah, that's okay. So that. What's that? Yeah, exactly. Well, because when you do like a miles to kilometers conversion, a mile is a mile is, I think, 1.6 0.21 kilometers or something like that. It's like 1,600 meters, roughly. But there's an error there, right, when it comes to precision. I'm going to skip the search demo because I don't really have anything loaded up to search really well. And we've got 15 minutes until we need to be done. So I'm going to skip that. I am going to show you here, though, however, for search, there are some SQL equivalents. This is more for reference. It's in the slides in the repo. And so if you're thinking in terms of like SQL, these are the Redis search equivalent types of commands you could use. So for example, here, if you want to, where number is greater than or equal to 10, you say @num:10 positive infinity. And there are some examples of where X is in foo bar or hello world. You can say @X: foo pipe bar pipe, and then hello world. That one's in strings and quotes there. It's probably safer to do it that way, but it's not required. So the next section of the workshop is to try Redis search. Basically, we could work on the exercise for 15 more minutes, and you could dive into JSON and search, or I could talk about one other Redis feature. Which would you rather have? More talk or more work? More talk? A little more talk, a little less action. Isn't that how that Elvis song goes? So the last thing I'll talk about then is a library called Redis Ohm, which is at the end of the exercise. Redis Ohm is for object mapping. This is a library actually that I created, so I am legitimately the world expert on this topic because I wrote it. I joked we wanted to do object mapping. We wanted to do like some sort of ORM tool for Redis, but we're like, well, it's not relational, so there's no R in it, so we just called it OM. And I'm like, well, we could say it's object Redis mapping, and we still call it an ORM, but my boss didn't go for it. So Redis Ohm is it's a layer of abstraction over top of search and JSON. That search syntax that I just went over, it's actually kind of a pain in the butt. You got to learn a whole new syntax that's different from anything else you've used for anything else in order to use Redis search. And while it's not like that hard, it's also just, it's one more thing to learn. And so Redis Ohm will do the search. It will build those queries for you, and then and let you map them to JSON documents and hashes. It's built on top of Node Redis. In fact, when you use it, you hand it a Node Redis connection. So if you've got a Node Redis connection from other JavaScript stuff you're doing, you can just hand it into Redis Ohm. It'll use the same connection, which is nice because then you can get to Redis and do all the low-level stuff you might want to do, but you can also work at the high level of abstraction. So you can kind of do a little bit of both. In Redis Ohm, you define your index using a schema. You execute basic CRUD operations using a repository class. And then there's a Fluent search interface that uses a search class. You almost never explicitly define the search class. You never instantiate it. The repository will return one, and then you can use it to build your query. And lots of times you don't even need to assign it to a variable, because you'll call like repository.search and then functions to build your query, at which point you're just stringing them together. So schemas define the structure of your data. They'll build the indices by calling ft.create for Redis search. And it converts JavaScript types to and from Redis types. So, for example, you have dates in JavaScript, but JSON doesn't really have a date format. And so it will convert them to numbers in your JSON document so that you can do time-based searches using Redis Search. Redis Search has some functions that allow you to do like time manipulation, that kind of stuff. The repository provides methods to create, read, update, and delete. And actually, it's not really create, read, update, and delete, because create and update are kind of the same thing in Redis, because everything's an upsert. If it doesn't exist, it creates it. If it does exist, it updates it. And Redis Ohm follows that convention. It creates the indices for your search. So the schema defines it and is the information to build it. Actually creating the index happens in the repository. And then it initiates searching using Redis Search. It all runs in Node, of course, and if you want to get it, it's npm install redis-ohm. Here's an example schema. So I've created a new schema. I've given it a prefix for all the keys in Redis, so everything here starts with citing. So everything will start with citing : and then you say, well, there's a type, there's a field called report ID, its type is string. There's tags, its type is a string array. There's verified, that's a Boolean. And so you're defining these in JavaScript types. And so this prefixes key in Redis. These will all map to tags. So if you say it's a string, it assumes that the tag is just one value. If you say it's a string array, it will take that value and parse it on a delimiter that's in the value. And if it's a Boolean, it actually can just take the true or false and convert it. And Booleans work as tags. The description is specifically defined as text, which is not a JavaScript type. That maps to a full text search. A common mistake people make is they'll try to use a text as a tag, because they look at the types, they say, well, we've got text, that's a string, geo, that's some position thing, we've got numeric, that's a number, and tag, I'm not sure what that is, but I probably don't care. And then they'll use text when they really wanted to use tag. So I broke them out here separately, and this one's called text, and it does full text search explicitly, and strings, so they've got different functions on them that do different things. Here we've got numbers and dates. Internally, these map to a numeric in RedisSearch, and because a date is just a number of milliseconds since the number of seconds since the beginning of the epoch. And then a point maps to a geo. The JSON path is implied, but you can be explicit. So behind the scenes, if I have something called report ID, and that's my field name, I will assume that the path is $.report ID. And so you don't have to specify this, it just figures it out. However, note that tags maps to an array. So it's expecting $.tags to contain an array and then returns all the contents of those arrays. So that's worth noting. You can override these and make them your own thing. So I want report ID to map to $.id. I want my tags is actually an object, and I want to get a value out of that object and treat it as an array. So I've got like tags : and there's an array of objects that have a property of name. So that would do that. Here I've nested objects, and so witnesses is actually $.details.witnesses and $.details.date. So you can map these JSON paths in your document to named things that you can use for searching in RedisOM and RedisSearch. If you don't define a field in your document in the schema, then it's not indexed, and very little conversion is possible. And so it'll just save whatever you provided. So if we go back and look at this index here, if I have some other field that's not defined here, like weather, then that weather will get written out and read out, but you won't be able to search on it. And like if one of those weather values is numeric, is like say a date, it's not going to convert it back and forth from a number to a date. Generally, the conversion, when you have missing fields, strings are still strings, numbers are still numbers, Booleans are still Booleans, dates and points are special. If a date or point is defined in your schema, then the code will convert it dutifully to a JSON number, a number in the JSON. So a new date, if you got a JavaScript date time, we'll convert it to the appropriately sized date or number inside of Redis. If you give it an ISO 8601 encoded string, it will recognize that format and convert it. If you give it a number, it will say, this number is a valid date, and write it out to Redis. When you pull it back out, it will always return a date instance. So you can shove it in many ways, but RedisOM is going to store that and return that as a date. Dates are hard. A point is defined as in the JSON from RedisOM as an object with a longitude and a latitude. When that gets converted into RedisOM, it gets turned into a string that RedisSearch can recognize. And when you read it back out, it converts it back to a latitude and longitude object. So this eliminates the error of getting these in the wrong order. If a date or point is not defined in your schema, then a date, if we get a date type, we know it's a date, and so we do convert it to a number. But when you read it back, it's going to be a number. If you give it a string with an ISO 8601 string, it's just going to store with a string, because it doesn't know that it could potentially be a date. It has no information about what it is. It says, well, here's a string. I'm not going to check every string you ever write to me to make sure it's a date. That'd be inefficient. So it just copies in there. If you give it a number, it stores a number. If a longitude and latitude is not defined as a point in RedisOM, then it will just put that JSON in there and then read it back out as JSON, and you won't be able to do any searching on it. So, to create a repository, once you have a schema, is you call new repository, you give it a schema, and you give it a connection to Redis. This is a Node Redis connection that you have called connect on. These are very cheap. Feel free to create them and throw them away. They're just a wrapper, they're just a bag of functions. So there's nothing expensive in creating them. Once you have them, you can take a JavaScript object here. So we've got a citing here with a report ID, some tags, a Boolean there. We've got some text field, a number, but you know, a point. We got all the things. And we can call repository.save, pass that object in, and then await the results, and it will return the object that I just added with 2 new fields, because it's now an entity. An entity is really just a JavaScript object. There's nothing special about it. It's just nested like any other JavaScript script object, except it's done some of the conversion. So you got that instance of that. Make sure that's a date coming back. And when you call save, it will add symbols to it of an entity ID. And I think there's the entity key as well in there, but it's not on this slide. But the entity ID is if you've used symbols in JavaScript before, it's a way to guarantee that no one else could define something with that same symbol. They're kind of like atoms in Elixir, if you've used Elixir, or like symbols in Ruby. And so there's a special field on here called entity ID, which is the generated ID that was added to it when you called save. So when you call save, it returns back what you saved plus an entity ID. And if you passed a number for a date, it converted it to a date when it brings it back to. Can you use your own entity IDs because it's just generating them for you? Maybe you want them to be something else. This is a common request. Yes, you can. If you call save and pass it an ID and an object, then it will then assign that an entity ID of 1, 2, 3, 4, 5. And then citing and the square brackets entity ID will be defined in there. We'll have that value. What this does, though, is that now that I have something with an entity ID, I can modify it and add a value to the tags. I can change the description. I can change the verified status. And I can just call save with that value again, and now it will update it as opposed to replacing it, because it knows the ID already. If you didn't have the entity ID on there, it would just keep creating new instances in Redis. So saving an entity with an entity ID, it actually does an upsert, because if you give it an entity ID ahead of time, like if I just hard-coded an entity ID into it and called save, it would still insert it, because Redis is just doing upserts behind the scenes. Removing and fetching is very easy. There's a fetch method. You give it an entity ID, 1, 2, 3, 4, 5, or a big long ULID or whatever. And if you want to remove, you call remove, and you give it to the ID. So these are pretty straightforward. If you want to search this, but this is just CRUD operations, right? Reading, writing. If you want to insert things, or you want to search things, you can call create index on a repository. And what create index will do is it will look at your schema and build the call to ft.create that it needs to actually build the index. But before it does that, it will look for a key in Redis that has a hash of the existing index. If that key exists, if that key doesn't exist, it goes ahead and just creates the index. If that key does exist, it compares the hash value in there to the hash value of the current index that is in your schema. And if they're different, it deletes the old index and recreates it. So you can just call create index in your code, and they will be current. Creates or recreates the index. And this is calling ft.create behind the scenes. Once you have that index, you can call search, which returns a search object. And the simplest thing to do is call return.all. Return.all will just pass a star in and return all the values. It's equivalent to doing this. I actually, just 2 days ago, I added an iterator to this, so you can say return.iterator. So you can do an asynchronous iterator against this as well, which is much nicer JavaScript code. So that's coming out here real soon. Oh, as soon as I get someone to approve the PR. If you want to find some of the things, we can say repository.search, and then there's a bunch of semantic or fluent functions on here. We can say where field name equals, so where report ID is equal to 1, 2, 3, 4, 5, and witnesses is greater than. And so there's a lot of filler words in here so that it reads like language. Like is doesn't do anything other than just return this. And then you can call greater than. You can also just say where EQ and GT. But adding these little filler words is cheap and easy. And verified is false. There's a not. There's an at. So I can say where witness is not greater than, or is not equal to, or is, I guess, is not false would work, but it'd be kind of silly because you'd say is true. But you can say a date is after, tag contains, so the tag contains woodlands. The description matches, so you use matches for full text and equals for strings. And location is in radius, and then you provide a circle object to it. Or it provides you a circle using an arrow function. And you can give it an origin and a radius, and all those sorts of things. And then you can say .return.all. There's also a .return.page, and there's a return count, if you just want to get the count. There's a variety of things that you can return. And soon there's going to be a return iterator as soon as that gets out there. Full documentation is out there at github.com/redis/redis-node. And I am practically the sole maintainer of that. So I think I've gone over by 1 minute. So you guys can work on this on your own afterwards if you are so inspired. But otherwise, thanks a lot for attending. And I actually timed that better than I thought. Thanks a lot.